Have you ever been in the top floor or in the attic of a house during the heat waves? Generally, in these spaces, you experience an elevated air temperature above the acceptable range in the thermal comfort standards. It is named overheating. Research showed that many energy-regulated houses have an overheating issue. The top floor of multi-level houses have significant overheating during summer and heat waves, which leads occupants to turn on the mechanical facilities. Hence, we face consuming more energy, requiring surplus for plants, and producing more greenhouse gas emission. One of the research areas of CRC for low-carbon living is improving indoor thermal comfort in the top floor of multi-level dwellings. This research for the CRC is being done as a PhD thesis in the University of South Australia by me. I am Sorme Sharifi. What is the definition of thermal comfort? Thermal comfort is that condition of mind that expresses satisfaction with the thermal environment. It means balance between losing and achieving temperature by our body. There are about 20 physical factors that determine thermal comfort, and some unmeasurable factors still exist. Two approaches are available to predict thermal comfort. The first is called steady-state approach. It believes in a steady indoor temperature throughout the year and is usually used for the spaces with air conditioner. The second is called field state approach, which considers the acclimatization of the human body. The use of this approach results in remarkable decrease in energy consumption. My research is to use field state to find the appropriate indoor air temperature. Meanwhile, it will apply the steady-state method for modeling. So, how am I going to conduct this study? This CRC research takes advantage of Crclcl Park in Adelaide, which is a net zero energy living laboratory. All the houses in this site have been ranked more than 6 stars. 9 multi-level houses in this site have been monitored and will be monitored for some years to come. As a result of this monitoring, the majority of data for measuring thermal comfort is already available. The rest of the data will be collected from the Bureau of Meteorology. 1 or 2 houses from Crclcl Park as test houses will be chosen, and the current condition of houses will be observed. The residents' experience of their thermal comfort will be gathered by both surveys and interviews. To find the techniques to improve thermal comfort, architectural design will be integrated with low-energy mechanical utilities through modeling. The assessment criteria are energy efficiency, high performance, cost-effectiveness, and feasibility. The energy efficiency and high performance are accessible by some software programs. Cost-effectiveness will be evaluated according to the International Standard Organization. The best solution will be installed and monitored in the test houses to validate its feasibility and effectiveness. I expect that outcome of this research provide techniques and guidelines for residential building design, recommendations for building codes, and finally indications some new factors for thermal comfort related softwares. Thank you for your time.